So we're going to look a little closer at the domain of different functions. And at this point, you should have completed the first part of the worksheet or activity where you identified some parent functions, their domain and range, as well as the domain of some other graphs that were given to you. And hopefully you saw some patterns, and we're going to look a little deeper right now at those patterns. So the domain is the set of input values for a function. We typically know our input functions as x values. So if I have a function, f of x is my output, those are my y values or my range. My input, my independent values, my independent variables are my x's, those are my domain. On a graph, domain is left to right because those are my x values. I look along my x-axis. For my range or my f of x, it's my dependent. I look bottom to top along my y-axis. So first, let's look at polynomial functions. Polynomial functions always have the same domain, unless, of course, it's in the context of a word problem. But if I'm just looking at a graph, polynomial functions always have arrows that go infinitely in both directions, left and right. So there's no domain restriction on my polynomial functions, whether it's quadratic, quintic, cubic, doesn't matter. It also does not matter if there's a transformation. So if I had something like x plus 5 squared or x squared minus 2, it doesn't matter. My domain for a polynomial function is always all real numbers. And that is going to be, unless of course we are in a real world context and there is some restrictions based on that. In symbols, you might see this, or you might see this. Both of those mean all real numbers. Let's take a look at our next function. So radicals with even roots. So for example, the square root, the fourth root, the sixth root, all of those. Remember, these are also equivalent to rational exponents. So if you see any of these as a function, they have the same features because they are equivalent to radicals. So if I look at my square root function, my range and my domain are not all real numbers. I'm going to look just at domain right now. So my square root function, my domain, starts here at 0 and goes to infinity. Or you may see it written like this. X is greater than or equal to 0. Here's another picture of a radical function, but it has some transformations. Notice it was moved right 1 and up 2 units. And here is the function equation that they gave us. My domain here starts at 1 and goes to infinity. Or this could be written as x is greater than or equal to 1. So what you might notice is that what's underneath the radical is going to be what affects the domain. And that's because these functions cannot contain a negative under the radical. If I have the square root of -4, that's equivalent to 2i. This is an imaginary or complex number. It is not a real number, and our domain only deals with real numbers. So in order to find our restricted domain, you're going to take your radicand, which is what's underneath the radical, and set it greater than or equal to 0. So if I go back up here to these two examples, this is y equals radical x. It would be x is greater than or equal to 0. There's nothing to solve. Here it was y equals radical x minus 1 plus 2. This would be x minus 1 is greater than or equal to 0. To solve, I would add 1 to both sides. There's my domain. Our next family of functions is rational functions. And you'll notice here, my rational function, remember, has a discontinuity. It has a vertical asymptote here at x equals 0. So my domain is all real numbers except 0. In interval notation, it would look like this. To the right, we have another example of a rational function. This time, notice this is my vertical asymptote, x equals negative 0.5. So I have transformations happening here. So my domain here would be x cannot equal negative 0.5, or if I'm writing it in interval notation, negative infinity to negative 0.5 with a parentheses, union negative 0.5 to infinity. Notice how both of these in both situations get a parentheses because I cannot equal that. It has to have a parentheses, not a bracket. Bracket means it's included, but an asymptote is not included. So these functions cannot have a 0 in the denominator because it would make it undefined. That's why we have an asymptote. So to find our restricted domain, you are going to take your denominator and set it equal to 0 and solve. So let's take a look at our two examples that we have up top. My denominator here was x. So this would be x equals 0. There's nothing to solve. My domain is x cannot equal 0, or all real numbers except x equals 0, because that could be given to you in words. All real numbers except x equals 0. Over here, I take my denominator, 2x plus 1, set it equal to 0, and I have to solve. So I get x equals negative 1/2, which is equivalent to negative 0.5, and there is my domain. Our last type of function is a logarithmic function. A log function also has an asymptote. If you remember, my asymptote for my parent function is on the y-axis. So I have a vertical asymptote at x equals 0. So my domain here, it starts at 0, but it has an asymptote, so it gets a parentheses, unlike the square root function, which gets a bracket because it's defined at 0, or x is greater than 0. This one has an asymptote, but it's a continuous function. Slightly different than our rational functions, which have an asymptote, but have a discontinuity. On the right, I have another graph for you. My asymptote is drawn in already at x equals 1. So my domain here would be parentheses 1 to infinity, or x is greater than 1. This was my equation. My transformations here were right 1 and up 2. And what you might notice once again is that what's inside my parentheses is going to affect my domain. And that is because logarithmic functions have an asymptote, which must be taken into consideration when determining our domain. You cannot take the logarithm of a 0 or of a negative number. So to find the restricted domain, you're going to take whatever is inside the parentheses and set it greater than 0. Let's go back and take a look at our two examples. So for this one, it would be x is greater than 0 because that's what was inside my parentheses. That's my domain. Over here, I would do x minus 1 is greater than 0. To solve, I get x is greater than 1. There's my domain. And the last note to take into consideration is that you have to always go with your most restrictive domain. And there's a couple of different situations that occur, but one example is a radical in the denominator. This combines two rules that I just went over. Radicals have their own rule and denominators have their own rule. So you must consider both and take the most restrictive domain. What do I mean by that? So if I have 1 over radical x, in the denominator here, this cannot be equal to 0. And normally, under a radical, has to be greater than or equal to 0. But I have to take the most restrictive, so I have to go with greater than 0. Because if I just went with greater than or equal to, it would violate this rule. So I have to kind of combine the two and make it the most restrictive. Let's take a look at some examples of all different types of functions. So example 1, g of t equals radical 2 minus 3t. This is under a radical. I'm going to take what's under the radical and set it greater than or equal to 0. And if you need to remember your parent function to help you, it looks like that. So I'm going to subtract 2 on both sides. Negative 3t is greater than or equal to negative 2. I'm going to divide by negative 3 on both sides, but please remember, with inequalities, when you divide by a negative, you have to switch the sign. So this would be my domain, but they're asking for us to write it in interval notation. So t is less than or equal to 2/3. If you need to, draw out your number line. So this is going to be negative infinity to 2/3 with a bracket. And there's my domain. The second one over here, this is an x cubed. This is a polynomial function, so there are no restrictions. All polynomial functions have a domain of all real numbers. Number 3 is a rational function. If you need to remind yourself of my parent function, it looks like this. You're going to take your denominator, p squared minus 4, and set it equal to 0 to solve. So I'm going to add 4 to both sides. You could, of course, factor as well if you want. Square root both sides, so p is equal to plus and minus 2. So that means my domain, I'm going to write it out in words first, is all real numbers except 2 and negative 2. So what that looks like on a number line is at negative 2, it's going to be open. At 2, it's going to be open. But everything else is included. So in interval notation, it's negative infinity to negative 2, parentheses, not a bracket because it's not included. And it goes from negative 2 again to 2, and then again from 2 to infinity. Taking a look at number 4 here, this is one where there's 2 rules involved. So if it was just in the denominator, it would be cannot equal 0. If it was just under a radical, it would be greater than or equal to 0. But because it's both, I have to take what's under the radical and set it greater than 0, not equal to. I'm going to add 7 to both sides to solve. So we get x is greater than 7. If you need to, draw out your number line. It's not equal to, so it's an open circle, which means in interval notation, it is parentheses. Going to number 5, what you'll notice again here is I have an x squared. So this is a polynomial, specifically a quadratic, but it does not matter because all polynomials have a domain of all real numbers. Last one, number 6. I have 2 things happening here. My denominator of x minus 5 cannot equal 0. And my numerator is under a radical, so it has to be greater than or equal to 0. So I'm going to add 5 to both sides. So x can't be 5, and x has to be greater than or equal to 0. I'm going to put this on a number line because I have two different restrictions happening here. So it's going to look like this, which means an interval notation. Bracket 0, because it's equal to, and it's a filled in circle, to 5, with a parentheses because it's an open circle and cannot equal, and then from 5 to infinity. And there is my domain. So there's some examples for you to try on your own to practice using all of these rules.